All right, hello and welcome back to Chapter 7, Lesson 5, Exponential Functions. I know we played around with our graphing calculator, the decimals calculator on our iPads on Friday, and we kind of saw what happened with those when we changed those numbers around. So graphing them today, we will be graphing about a half a dozen, and just like linear equations, we are going to start with those, the -2, -1, 0, 1, and 2, and graph those, and maybe even 3, and see how that goes. Okay, so right here we've got examples of exponential functions. They are in this form: a times b to the x. Okay, so a can be a number, and b, or it has to be a number, excuse me, and b has to be a number. Obviously a cannot be 0, because if you took anything times 0, it would be gone. So that's why it says a cannot be 0. We talked about the fact that b, the number we're raising to a power, it has to be greater than 0. It can't be negative, because a negative would be positive, then negative, then positive, then negative. And then it can't be 1. Well, it can be 1, but if it's 1, it's not an exponential function, just because it makes a flat line. So it's going to be a number either less than 1, between 0 and 1, or it's going to be greater than 1. We did talk about the fact that this one is going to look like this, and this one is going to look like, oops, this, not that. Okay, if it's greater than 1, it's going to go up to the right. If it's less than 1, it goes up to the left. So a J or an L. All right, so let's just plug some numbers in there. As I was saying, 4, 5, 6, 7. So I'm going to put a 0 here, and I'm just going to go -1, -2, -3, because that's how many they gave me. If I start with 0, 0 is kind of nice. So I'm basically 5 to the third, 5 to the second, 5 to the first, 5 to the 0, 5 to the -1, 5 to the -2, 5 to the -3. So this is 125. Obviously, we are not graphing that one. It's going to be huge, not going to fit on there. This would be 25. That one also may not fit on there. Then we have 5, we have 1, we have 1/5, 1/25, and 1/125. All right, so excuse me. So 3 is way up there. Even 2 is way up there. 1 is at 5. 1, 2, 3, 4, 5. 0 is at 1, because any power to the 0, any number to the 0 power is 1. -1 is at 1/5. Then 1/25, then so on and so forth. So here is our graph. And like I said, to be expected, the large ones won't fit on there. Okay, and that's all right, as long as you have an idea of what's happening. Now, they're going to ask us to state 3 things. 1, the y-intercept, which is where does it cross the y-axis. So in our case, 0, 1. The domain, that means what values for x are there. And you'll notice, is there any limitations on what I can plug in for x as an exponent? We learned this in the beginning of this chapter, that there isn't, as long as it's a real number. So I'm going to say all real numbers. But on this one, the range, the values for y, if we notice, it's never going to go below 0. So y, the range is y is greater than 0. It will never actually equal 0 either. It'll get infinitely smaller, but it will never equal 0. Okay, so that's one example. Notice it talks about the fact that a has to be greater than 0 and b has to be greater than 1. So when a is greater than 0 and b is greater than 1, it is going to be a J-shaped. It will go up as it goes to the right. All right, now we're going to graph one where b is between 0 and 1. So notice we have a 1/4 to a power. On this one, there's not as many, so I'm going to do -1, -2, -2, -1, 0, 1, and 2. So I got 1/4 to the -2, 1/4 to the -1, 1/4 to the 0, 1/4 to the first. I flipped these around, sorry about that. 1/4 to the second. So that's 1/16. This is 1/4. This is 1. This, the negative reciprocal, actually flips it, makes it a positive 4, and this is a positive 16. So at negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. At 1, 1, 2, 3, 4, and then we're at 1, then we're at 1/4 and 1/16. So in this case, with B being between 0 and 1, it is an L shape. Where the other one was a J shape. All right? So once again, what is our y-intercept? Oftentimes, and we found this out on Friday, that it will oftentimes be 1. The domain, is there any limitation on our x values? There are not. I could plug in anything as long as it's a real number. So all real numbers. Range, again, is above 0, so y has to be greater than 0. And then it says, then use the graph to approximate the value of 1/4 to the 1.5. Well, that would be about right here, right? 1.5. So where does our graph, where would that be? Probably pretty close to, like between, it's between 1/4 and 1/16. So I would say probably 1/8-ish, 1/8, approximately 1/8. Okay. Turn the page. So here's where it talks about this. As long as your B is greater than 1, it will be a J shape. So as long as A is greater than 0 and B is greater than 1, it's going to be an A shape. If A is greater than 0 and B is between 0 and 1, it will be a J shape. That's a fraction or a decimal value that's being raised to a power. Okay, and take a look. It says all real numbers positive. The y-intercept, one y-intercept, there will not be any x-intercepts. Same thing for this one. One y-intercept, no x-intercepts. The range, it will be all positive for both of these because they don't go below. And then the end behavior, as x increases, y increases. As x decreases, it approaches 0. It will never actually be 0, but it will get infinitely closer and closer. So the end behavior on this one, as x increases, f of x, which is referring to the y value, approaches 0. As it decreases, it increases. Okay? So we're going to use exponential functions, and we are going to solve word problems. Now, we're not going to write word problems, at least not today, but we're going to solve them. Okay, so take a look at this. It says a certain bacteria population doubles every 20 minutes. Beginning with 10 cells in a culture, the population can be represented by this function. So the population equals 10 times 2 to the t. And if you're picking up on some of this, 10 is the original value, 2 because it doubles. We don't have to write them, but it's interesting to think about that. To the t power. B is the number of bacteria, t is the time in 20-minute increments. So it's every 20 minutes adds 1. Okay, so how many will there be after 2 hours? So first of all, in 2 hours, how many increments of 20 is in 2 hours? And that would be 6. There are 20-minute sections, 3 of them in every hour, so 6 of them. So we're going to plug in to this equation, B equals 10 2 to the 6th power. Now, I know, and maybe you guys do, that 2 to the 6th power is actually 64, because we do exponents before we multiply. And I don't know why I put 16 here. And so bacteria is 640. Okay, 640 back. We started with 10, 640 after 2 hours. That's how quickly bacteria grows. Okay, let's do another word problem. Recall that from 3 linear functions have a constant rate of change. Exponential functions don't have constant rates of change, but they're going to have a constant ratio, meaning between each value, as long as x goes up by equal increments, it has to be equal. Like our example here was every 20 minutes. So this one, x is every 5, and then it has to be a constant ratio, meaning you're being multiplied by the same amount. Now remember, division can look, or multiplication can look like division if you're multiplying by a fraction. And why do I say that? Well, because what did we do here? 1/2, 1/2, 1/2, 1/2, 1/2. That is a constant ratio. We're multiplying by 1/2 every time. So do the domain values have regular intervals? Yes, they do, because they're going by 5s. Do the range values differ by a common factor? No. It has a common ratio of 1/2. So let's graph it to be sure. So this should be, yes, it should be exponential, but let's graph it just to make sure. I am going to go by 5s on the y, or on the x, excuse me, 15, 20, 25, just so I can squeeze them all on here. And maybe, can we do 5s? 10, 20, 30, 40, I can't, dang it. Maybe I can, 40, 50, 60. So I can't fit that first one on there. So 0 is not going to fit on there. 0 is at like 64. It's way up here, right? Not going to worry about that. 5 is at 32. 10 is at 16. 15 is at 8. Then we got 4. Then we got 2. It would be at 1. It would be at 1/2, and so on and so forth. So is it exponential? The answer is absolutely. Okay, yes. Okay, second page or third page for you guys. One more time. So will it be exponential? So we look, is this going up? Is the x going up by an equal increment? Check. Yes, they are. But what's happening here? Are we multiplying or dividing by something, or are we just adding or subtracting something? And this looks like we're minusing 4, minusing 4, minusing 4, minusing 4, minusing 4. So guess what? While this is yes, yet it's a differ by a common factor. Yes, it is -4. So is it exponential? No, it is linear. And we can graph it just to be sure. The x is going to go by 1s. Can we do this? 10, 20, 30, 40, 50. So 0 is 50. 1 is 46, 42, 38, 34, 30. See how it makes a straight line? So it's not exponential, it is linear. Okay, just one more thing I just want you to think about in terms of our equation, y equals a b to the x. That b, the number we're raising to a power, it's got to be positive. It can't be negative. And we talked about this on Friday, but I'm just reiterating it. So it's not going to give you an exponential function if it's not. Okay, and you can read through that and we can talk about it more later. All right, so your assignment is going to be on this piece of paper, and you do have a copy of that. Notice we've got some funky, but there's only 11 questions, and you will be graphing them. Now I've got some graph paper that I would recommend for you. Remember that for each one, not only are we graphing them, but then we're stating the y-intercept and the domain and the range. So if we look at number 10 together, number 10, and I'm going to make the table right away. I'm going to go -2, so it's y equals 2, 8 to the x, right? -1, 0, 1, 2, whatever. So if I put -2 in there, negative 8 to the, well, I can do this one. That one's easy, right? This one's going to be 16. This one's going to be 8 to the second is 64 times 2 is 128. Zoiks. And then 0 is going to make the 8 1, and 1 times 2 is 2. If I put -1, that becomes a 1/8, and 1/8 times 2 is 1/4. And if I put -2 in there, 8 to the, that'd be 1 over 64, which would be 1 over 32 when I multiply it by 2. And then we can graph it. Now, when I graph it over here, all right, now I'm going to go, my x's going to leave them, just go by ones. But my y's, folks, you know, I'm got to be, can I go by twos? 2, 4, 6, 8, 10, 12, 14, 16. Okay, so I can't even graph this one on there. I'm not going to worry about it. So 2 is at 128, way the heck up there. 1 is at 16. 0 is at 2. -1 is at 1/4. And then 1/32. And there you have it. You're going to do the best that you can. So y-intercept is 0, 2. Domain, all real numbers. And range, y has to be greater than 0. Okay, so good luck. Make sure you come to me with questions if you have any during SRB, or I'll talk to you tomorrow. Thanks. Bye.